Okay. So 6 points. The initial B rate reading for the rough is what? Initial B rate reading is what? 6 point what? 6.3 cm cube. Okay. So you can start your titration now carefully. Use phenolphthalein as indicator. Phenolphthalein. More. Okay. Easy. Rushing that thing is okay now. Hi. What's the value? Huh? 15.2. 2.2. Or is it 16? 15.2, correct? Okay, so let's go to the next one. So you carry out the next one. So 15.2 is my initial. So we're leaving it at 15.2, right? Good. So do another one. Sherifat, you're rushing. Where are you rushing to? But if you like, you can use you can still use methyl range now for convenience. So we'll go to methyl range next. See, see. Just adjust it small like that. Add a little more. It's okay. Let's go. No, don't rush that thing. Once it changes, continue. Aha. So what's the value there? Hmm? 20 what? 27.3 cm. You can fill the acid again. Fill the acid so that add more acid using the funnel. So you can go and be subtracting for me. It's okay. It's okay. It's okay. Just get that reading for me. What's that reading? Remove the funnel. That's one of the precautions. You have to make sure that the funnel is always removed, right? So what's that reading? Somebody should go and punch calculator. The difference between this for me. You can get the difference. Go and get the difference. What's the reading there? Initial reading for the second. What's the initial? Daniel, can you give me that reading? What's that reading?
4.27.
4.2. Sure? Sure? So 4.2 is your initial burette reading. 4.2. So, okay. Phenolphthalein next. Okay, so you can use phenolphthalein. Okay, stay. Sharifat, stay. 8.9 for the first one. This minus that. No. Are you sure? 8.9, okay. And this minus that. It's okay. Sharifat, stay. Okay. Okay. 12.1. Good. What's the value there? Now, because of there's an issue here, we got 12.1, right? Okay, so we're going to say 12. Let's see, 16.2, 16.2, 16.2. Okay, so do the next one. So subtract. So that'll give you 12.0, right? Correct? I just hooked up the value, if not the video. So the next one is what? What's the value you have there? You have 11.2 there, right? Where's your calculator? Go and get the calculator. So let's go. It's okay. It's okay. So what's the value? 23.6, right? 23.6. Yeah. Okay. So yeah, roughly, yeah, it's at 23.6. So now subtract this minus that. Let's see. 12.4. So so our average volume of A used. So how do we get the average volume of A used? It's going to be first plus second plus third divided by 3, correct? Good. So our first reading is what? 12.1 plus 12.0 plus 12.4, right? So that, what would I give you? So 36 point what? 5 divided by 3, I'll give you what? So 28, 36.5 divided by 3. 36.5 divided by 3. 12.16 cm cube. So this is the average volume of what? Of acid used, okay? So let's get the equation of the reaction so that we can calculate the concentration of B in moles per dm cube, right? Now concentration of A, from the question, concentration of A might be 0.1 mole per dm cube, right? Right? We know that volume of the acid is what? 12 point what? 16 cm cube, right? Our volume of base is what? 25.0 cm cube, correct? Correct? Good. So let's calculate the concentration of the base, right? Cb. Okay, so that might be the question you're asked to, what you're asked to calculate, right? So, but from the equation says, so let me just, I think I have to clean this so that I'll get the equation. The equation says, okay, let me, the equation is between H2SO4, right? So aqueous sulfuric acid plus sodium hydroxide, aqueous. So that will give you sodium sulfate, aqueous, plus water, correct? So which is liquid, correct? So we have to balance this equation. So in order to balance that equation, in order to balance the 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 equation, we have how many moles? We have how many moles? For water, we have 2 moles water, 2 moles of sodium hydroxide. Is that okay? Good. So the equation should be balanced now. So Na will be equal to 1 and Nb will be equal to 2, correct? So Na, Nb, correct? So our equation says concentration of acid times volume of acid divided by concentration of base times volume of base is equal to Na over Nb, correct? Good. So what's the concentration of the acid from the question, right? The concentration of the acid might be given to be 0.1 mole per dm cube. So we have 0.1 times the volume of the acid used is 12.16 divided by concentration of base is what we're looking for, correct? Volume of base is 25 is equal to what is Na? Acid is 1 ratio what? 2. So I'm going to have to cross multiply, right? I'm going to cross multiply. So if I cross, we're going to get, so let me clean this because we don't have much space to do that. So we have 2 goes there, so we have 2 times 0.1 times 12.16 is equal to, so we have Cb times 25, correct? So our Cb, I have to divide both sides by 25, correct? So divide here by 25, divide by 25, right? So 25 goes with 25. So concentration of base in mole per dm cube, Cb, is equal to, so 2 times this gives you what? 0.2, right? Times 12.6 divided by 25, right? So what is 0.2 times 12.6? I'll give you what? I'll give you 20 what? 2.5. 2.5. So 2.52 divided by 25. So 2.52 divided by 25 gives you what? 0.10. So 0.10 mole per dm cube, right? So the concentration of the base Cb is 0. What? 1 mole, approximately 0.1 mole per dm cube. So that's the concentration of the base there, right? And the base is sodium hydroxide, correct? From that equation, right? So now you might be asked to calculate the concentration of the base in grams per dm cube. Now this is in moles per dm cube, right? So if you're asked to calculate the concentration of B, Cb, right, in grams per dm cube, this is what you're going to do, okay? So I have to clean one of that so that so this is what you're going to do, okay? If we were to calculate concentration of B, right, in grams per dm cube. Okay, so you see that's called mass concentration. You see mass concentration is equal to molar concentration times molar mass. Now, you know we're dealing with sodium hydroxide, right? So the molar mass of sodium hydroxide should be around 40. But we can calculate. Sodium is 23, right? 23 plus oxygen is 16, right? Hydrogen is 1. So if you add this up, you're going to get 40. So, but our molar concentration is what? 0.1, right? And the molar mass is what? 40, correct? Correct? So 40 grams per mole, okay? So 40 grams per mole. So 0.1 times 40, that will give you 4 grams per dm cube, okay? So the concentration of B, concentration of B, or the mass concentration of B, you might say mass concentration of B, or the concentration of B in what? In grams per dm cube. So you just multiply by the molar mass. The molar mass is 40. Is that okay? So you see we've used this formula to calculate the what? The molar concentration of B, which is this mole per dm cube, and we've now calculated the mass concentration, which you always multiply the molar concentration times the molar mass. That gives you the molar concentration, sorry, the mass concentration. Is that okay? So that is how it's done. So this is the table, and that is that. Any problem? Any problem? No problem. You're sure, correct? Good.